Good morning, friends. This is Durga from ITversity, one stop shop to learn all the technologies. So at this time, we are in the middle of Scala and Spark workshop, and this is the backup for one of the live sessions going. So let me set up the Webex session, and then we will start. Okay, I'm just validating that you guys can see my screen. Yes, it looks good. And once I start in the Webex, we'll go ahead and start. Good morning, friends. Let me mute everyone. And I'm sharing my screen. There is someone who didn't mention their name in the Webex. Please add your name so that we can communicate more effectively. So let us go ahead and start with today's session. We are in the middle of data frames. Yesterday, we primarily focused on case classes. I hope everyone is clear on that. So if you are using IntelliJ and if you have defined dependencies as part of build.sbt, like this, okay, you can use your PC itself to validate to validate whether data frames is working or not. You don't need to log into lab. Yesterday I have shown primarily on lab. Today I will be using this existing SBT based project. Okay, so the steps that are involved: first, you have to create a Scala project like this. So when you say new project, here you have to choose Scala and choose SBT, and then when you actually finish, it will actually set up Scala environment on IntelliJ. Okay, and then you can go to build.sbt and add this library dependency to develop Scala based code. And as I have mentioned earlier, you can use the Scala version and the Spark version which you are using has to match. In this case, I'm using Scala 2.10.6 for this project. And also when it comes to Spark code, I am using 1.6.2 compiled with Scala 2.10. I have mentioned that very early in the course. And now, if we actually add Spark Sql to this, again, it's an additional dependency. Yesterday, I have shown you on the lab. How did we do it on the lab? We just connected to the lab. And then we just start Spark shell with the master yarn client, and automatically your Spark context and Hive context will be created. Spark context is SC, and SQL context is SQL context. Your Spark context and SQL context will be automatically created. When you have SQL context, then only you will be able to use data frames. Otherwise, you will not be able to use data frames. Okay. So here to add Spark Sql, first we need to identify the dependency which we need to add as part of the build.sbt. So here you can say Spark Sql SBT and hit enter. It will take repository.com. Use this one. Okay, and this need not be the latest version. Let us see whether we can use this or not. Most likely we will be able to use. And again, we have to actually check on the lab which version of Spark Sql we have. So that you can actually run find command like this. Find. You will not be able to use slash, which is root to file system. And then we can say Spark Sql. Let us see whether we can retrieve any information from here. Okay, so this is the Spark version. We want to use 1.6.2. and this is actually, I think, Spark SQL version or HTTP version. I'm not 100% sure. Let me figure out which one we have to use. This is HTTP version. This is your Spark SQL version, which is 2.0.0, and this is your Scala version. Okay. So in this case, yeah, we will be using 1.6.2 itself. We will not be using 1.0.0 or 2.0.0. So let us use 1.6.2. Okay, I'm just copying this one and pasting here. And instead of 1.0.0, Spark SQL also I want to use 1.6.2. Okay, we need to use compatible versions. In this case, this is Spark SQL version, and this is the version of Scala which is used to compile this Spark SQL 1.6.2 jar file. Okay, and here you can see the Scala version. So our Scala version to develop the project should be same as or compatible with whatever Spark versions we are using here. Okay, when we actually do Spark shell, the Spark shell will have all the jars registered to it, and also it will create some implicit objects which we can directly use. Okay, so it might take a few minutes. Let us see. If it does not, if it is not done, then we will proceed on to the lab and try to do it on the lab. Once again, I am explaining. Whenever it comes to the development, you have to use your PC to develop. You should not develop on the production cluster directly. You should use your PC. For that, you need to have the SBT integrated Maven, SBT integrated Eclipse, or SBT integrated IntelliJ. Okay. In this case, I have IntelliJ with Scala and SBT. And the way you have to do is first create a Scala project by going to File, New, Project, and then make sure you choose Scala and then SBT here, and then you can click next, and you have to choose auto import somewhere. So for example, if I click next here, probably it will be slow because right now this has the lock on IntelliJ, which is actually refreshing our repositories. So let's wait for a few 1 or 2 minutes, and then we will see. Yeah. So now you see here, this is project JDK, this is SBT version. If you want to use 2.10.6, you can scroll down here and choose 2.10.6 because we want to set up 2.10.6 as our Spark versions are 1.6, which is compiled with 2.10. And then make sure you choose auto import. If you don't use auto import, when we save on build.sbt, it will not kick off refreshing the dependencies. Okay, so make sure you choose the auto import, change the project name, and then finish, and then it will set up the environment for you like this. You will have, after a couple of minutes, you will have source directory, you will have build.sbt and few other stuff, and then open the build.sbt. You will have only these three things: name, version, Scala version, whatever you have chosen. And then depending upon your project, you have to add the dependencies. If it is Spark-based project, you have to add these two things. If it is Spark-based project, you just have to add Spark core. If it is Spark SQL, you have to add both Spark core as well as Spark SQL. And then for externalizing, we can use typesafe config. And for MySQL, if you want to write some JDBC code, you can actually define the MySQL connector dependencies also. Okay. Now, once the dependencies are resolved, we have to go to this directory, idea projects W labs, and here you can see tilde after my W labs, which is project name. You can see tilde, then idea project, then W labs. Tilde is nothing but my home directory on my local machine. Okay, so if I say cd space tilde, it will take to my home directory, and this is my home directory, user site university. In this, I'm going to the idea projects, and I'm in W labs directory, where that is my application name. and then you can see source, build.sbt, target, project, etc. So whatever you are seeing here is visible here. Okay. Now if you run sbt, launch sbt and type console, or you can directly say sbt console. Okay. So the advantage of using sbt console to launch Scala is all the dependencies which are defined as part of build.sbt will be available for this session. Directly from here, we can actually start developing our Spark applications. Okay. So first thing you need to do is make sure you run import command org.apache.spark.spark context and then spark const. If the import is successful, that means we have all the dependencies resolved for this project, and then we can start whatever we want. Now let me go back to what we are talking. We are talking about data frames. I just recap the way you should set up the environment on your PC using IntelliJ. If it is Maven, if it is Eclipse with the Scala IDE plugin, and if you are using SBT, what you have to do, you have to go to your directory, project-based directory, and then go to build.sbt, or even from Eclipse also you can open build.sbt and add that line for Spark SQL dependencies, and then you can actually run SBT package and SBT Eclipse. Then all the dependencies will be resolved, and also your class paths for the Eclipse will be updated. As of now, on my laptop, I don't have Eclipse with Maven. If you guys are trying with Eclipse plus Maven and SBT, and if you want me to show by sharing your screen, I can do that as well. Okay. If you run into any issues, let me know. I will do the screen sharing, and I will try to demonstrate how to do it in Eclipse with Scala IDE and SBT. Okay. Make sure you use only SBT. Don't use Maven to actually develop these projects. Okay. Now we are in the command prompt, right? So now I'm going back to my course page, IT University courses. Okay, I didn't start recording. I'm forgetting starting recording. So here I'm showing how to start on data frames wherever we have stopped yesterday. So I'm taking to the page, Big Data Engineer MFM. In this you have Apache Spark data frames. And yesterday we have seen what is case classes predominantly. And now we'll start using those case classes, convert it into data frames, and we will take it from there. So here I am trying to import all these things. Okay. And then I am trying to create a case class. So case class will come with, case class is nothing but a class which have getters, setters, and a few other helper methods. On top of that, it will also have a companion object with apply method. Because it has apply method, we don't need to invoke apply method to if you want to build the object. Okay, we will see that. We will see that now. And now we have to create the const object like this, and then we have to create Spark context object. When we create Spark context object, then only it will actually launch the web service, and we will be able to start executing these Spark-based applications. Once you create Spark context, we have to create SQL context. Okay, in this case, which SQL context we are importing? It's under org.apache.spark.sql. Okay, so it is native Spark SQL context. We are actually creating native Spark SQL context. On our lab, when we actually run Spark shell, it actually starts in Hive context. So let me open another tab here. Now I am actually getting onto the lab. Okay, root at gw01.itversity.com. Now I'm launching Spark shell with master as Yarn client. Okay, there is some issues. I guess a lot of guys. Okay, already it have reached the maximum retries. If you are running into this issue, you can say spark -shell -conf and then spark .ui.port equal to 10203 and hit enter. Okay, it is running in local mode now because I forgot to mention --master yarn client, but that is fine. Now it will launch successfully. Okay. Now, if you say yes, SC, it is nothing but Spark context. And then there is one more context called SQL context. If you say SQL context, it is actually of type Hive context. It's not the native Spark SQL context. Okay. So using this, you can actually run Hive queries. But if you want to create data frames and register template tables, what is a data frame? You will be able to create a template table on the fly if there is a structure in the data using a programmatical approach. And if you want to use such kind of stuff, you have to create the context with SQL context. So either you can actually change this SQL context to one minute. To this one, Spark.apache.spark. So we can actually do this. We can copy this one and paste. I'm in the lab. This is the lab one. So I'm pasting this import statement. And then I can say val SQL context. I can give the same name and it will kill the Hive context and create new object with native SQL context, or we can create a new variable altogether. In this case, I'm giving it as SQLC, and then we can say new SQL context SC. Okay, and SQL context runs only in Spark context. So first you have to create Spark context object, and you have to pass Spark context to SQL context. Okay, now you can see this SQLC is of type Spark.sql.sql context. Now we can actually issue queries using this after creating the data frames. So you can choose. Now I have two environments, one in local and the other one in the lab. Yeah. So let me show it on local. Let me show where my data is locally. So I have a directory called research data and retail_db. And if I say ls-ltr, there are tables like orders, order items, etc. Okay, now let me see what I have in that. The data is nothing but comma separated, and it has 4 fields. So based on that, I am creating the case class. Okay, and the case class looks like this. I'm creating, I think I have already created, so I don't want to create again. After importing SQL context, you have to run this also. Only then some of the functions will be available. If you don't import SQL context.implicits._, then you will not be able to invoke this 2df function. Okay, so immediately after creating SQL context, you have to run this import command, import SQL context.implicits._. Okay, so here I'm going to my local SBT based project, SBT and IntelliJ based project, and I'm importing. Okay, I didn't create the SQL context yet. Okay, so I'm in the middle of this thing. So let me create first SQL context, and also let me just make sure that I have orders case class. I'm just copying this one. Okay, so based upon the data type of each attribute, I just gave int or string in this and hit enter. And then because now SQL context is created, I'm making sure that it is SQL.SQL context, Spark native SQL context. And now I am importing this one. Okay, now SQL context implicits are imported. Now we have to transform our comma separated date as some comma separated data in our file. What is our file location? This is our file location. Okay, so I'm actually creating a new RDD. sc.text file. This you cannot avoid. You have to say this sc.text file and read the data. Now orders will have the our records in the string format. You can see the data type here. Orders is nothing but RDD, and each element is of type string. Now we have to apply math function, and as part of the math function, we have to invoke orders.apply method, and then create orders object, and then create RDD of orders object for each record. So this logic will take care of that. Okay. So here I am saying val orders ds equal to val orders ds equal to orders dot, and then one minute. Now map function is done. As part of it, what I have done, I just split each record, and that record will become array. In each iteration, each record will become an array, and then we are passing that array and trying to build the orders object. And then we have to say 2ds to convert it into data frame. Okay, I just have to give the I have to give this. I don't know when it will. Okay, I didn't create the orders object, orders class. I have created it. Then why it is complaining? Let us see again. Yeah. Now you see, it has created a new this new variable orders df is of type data frame. Okay, and you can see the structure of each record in the data frame here. Okay, and now we can apply data frame operations. What are the common data frame operations? You can scroll down here a little bit. Let me see where I have that. Yeah, I think here. I have documented those common data frame operations. Yeah, you can see here. Print schema, show, select, group, add, sort, and many more. So let us explore those things. So these are data frame native operations. Okay, you don't need to use this. If you want to write SQL, you can write SQL also. So the idea of data frames is whatever is convenient to you, you should be able to use that API to process your data, and underlying execution will remain same, whether you implement data frame operations or whether you implement your requirement using SQL. As long as the abstraction layer is data frames, the execution will remain same. Okay, I will give an example that will make a lot more sense to you. So it seems there is an issue. Is it for everyone, the lag between audio and video, or only for Ramesh and Rohit? The voice is breaking. What about you, Ravindra? Ravindra, are you there? So is it good for you, or is there any issue with respect to? Yeah. So I think it is the issue with Tawant. Okay. It can actually run the speed test to make sure that there is nothing wrong on my side. You also can run speed test and see how it is on your side. Yeah, from my side it is fine. You just have to make sure with respect to Tawant network. You can see it is stable and it is wired, so I don't see any issues from my side. Okay, so let me proceed. You can watch later. But if you want me to reiterate anything, let me know. I will reiterate. Okay. Okay, I'm running on the wrong window. That's why there is a confusion. Okay. So now I'm running that map function again here. Okay, I have to create the orders. So let me close this lab session so that I don't confuse. Okay, I'm closing this, and now I am using my local machine. Okay, and now I am actually copying this one. So now let us see the data frame operations. Now, once you create the data frame, you can use orders, the data frame name, which is orders df here, and say print schema. It will give the schema definition of your data frame. You can say show, and it will display few records from the data set. Okay, it has from 20 records, and you can see the column name here, and these names are retrieved from the case class which we have created. Okay, and if you want, you can actually apply select command to select the data. You can use group, you can aggregate by using ag. You can sort the data. You can do whatever operation you want. So there are few examples here, and what I'm trying to do is after creating orders, if I want to filter on the orders RDD, the filter will look like this: orders df.filter, and then this is our data frame name, and this is the column name. Okay, so this is kind of a table name, and this is the column name. And if that column equal to complete, then only I want to get the records. Otherwise, I don't want to. Okay, so once the data frame is created, you can apply filter to implement where condition on the data frame. And you see, this is nothing but our data frame name, and then the column name here. And also the filter is an API on data frame. This filter is different from the filter which we have used earlier. Earlier, all filter, map, etc. are on top of RDD. Now this filter is from data frame class, not from RDD class. Okay, so you need to know the difference. And when you are applying filter on data frame, the first thing should be the data frame name and then the column on which you want to filter. And to do equal, you have to use this, and then you can pass the condition, means you can pass the value against which you want to filter. Okay, then you can hit enter, and then if you want to see the results, you can run orders filtered.show. It will show the filtered data. Now you see only completed records. If you want to see only few columns, you can say orders filtered dot select, and in the select you can give the columns which you want to see, like this order underscore ID. Okay, and then show, and then it will only project your columns which you have mentioned as part of select. Okay, if you want to select more, you can just say, I think you have to say like this. Let me try it out. Order date. Yeah, so you have to pass it like this. Order ID, order date, and then it will project whatever columns you want to project. Okay, now we filtered the data. What was our problem statement? We just want to get total revenue for each day for completed and closed orders. So if you want to also get closed in the filter condition, you just have to go back, and here you have to say filter orders df order status equal to complete, or orders df order status equal to closed. Probably there could be in operator also. You have to explore that, and you have to use whatever is appropriate for your case. Once we get closed and completed orders, now we want to get order items data so that we can join. Okay, I'm using the same problem statement which I have demonstrated earlier for regular use case using core Spark APIs. Now we are trying to implement using data frame operations, and then we will see how to implement that using Spark Sql also. Okay, so now I have created case class for order items. Again, we have to use the map function to map the data. Okay, so here I am directly creating data frame. sc.text file, and the location where my order items is here. Order underscore items. Okay, and then I can use the rest of the logic. Now we have the order items data frame also, and to confirm that everything looks good, we can run show command and make sure we get the results. Okay, now we have orders and order items. Orders are already filtered. We can use orders filtered, and then we want to join these two on order ID. So this is how the join look like. If you see the join condition, orders filtered dot join. So this join is again from data frame. So once we apply filter on data frame, the output is also data frame only. So if I say orders filtered here, it is of type data frame. Okay. So whatever operation we are performing on that will be from data frames class. And in this case, I am trying to join orders filtered with order items ds. And when it comes to RDD join, we have to first create key value pairs, and then just have to say orders filtered dot join order items. That's it. But here it's not key value pairs. We are trying to join data frames, and we can actually specify the column names the way we are doing here. So if you see, I'm trying to join orders filtered with order items, and then the join condition is this. Okay, so it will look like this. Val orders join equal to orders filtered dot join order items ds, and then I have to give the join condition, which is all orders filtered order id, and for equal to we have to use triple equal order items ds order item order id. That is the column name for parent for the order id in order items, order item order id. Okay, and then close it for join, and that's it. Hit enter. Now you can see the output is of type order id, is again of type data frame, and it will have all these columns: order id, order date, order customer id, order status from orders, and order item id, order item order id, order item product id, order item quantity, order item subtotal, and order item price from order items. Okay, now we can use this to aggregate. So what is our requirement? Our requirement is to group by order date and get the revenue, and this is how we can do. We can say orders join dot group by, and which field we want to group by? We want to group by order date, and then we want to aggregate, and as part of the aggregate we want to do the sum. Okay, sum of order item subtotal. So aggregate functions has to be invoked using ag, and there are several aggregate functions that are part of the implicits which we can use. So as of now I'm using sum. If you want to know more functions, you can go to that Sql Context dot implicits, and you will see all the methods that are available. Okay, and this will aggregate the data group by order date. And once we get the results, if you want to sort, you can say sort and give the column name on which you want to sort that data, which is order date here, and then we can say show and hit enter. And now it is actually running the aggregation logic on the joint data set. And it gives the results. It is order date and the revenue for that day. Okay, is it clear? These are simple data frame operations. Again, if you can think from SQL perspective, understanding this is pretty straightforward. Where condition is applied using filter, join is done using join, and if you have to aggregate, first you need to group by on which key you want to aggregate, and then invoke aggregate function, and as part of that you can use several aggregate functions like sum, min, max, etc. And then if you want to sort the data, you can sort. And here, once you get the results, if you want to save it into a text file, there are multiple ways to do that. From data frame, you can directly save it into a file, and also you can convert it into RDD. And once you convert it into RDD, you can actually use save as text file and save the output to output path. Okay, so this RDD will convert your data frame to RDD. So at any point in time, if you are looking for transformation which is not available in data frame but available in RDD, you can convert the data frame to RDD and then you can run it. You can once you convert into RDD, whatever APIs that are available on RDD, you can apply those things and take care of those requirements which cannot be served using typical data frame operations. And this is how complete program looks like. Okay, you can use this code and try to explore the data frames in depth. Okay, I'm not giving any exercise in data frames. I'm covering data frames only for information purposes. Typically, we tend to use Spark SQL than data frame operations. But if you want to get it done, whatever you have done earlier as an exercise, which is to get the revenue by date and by department, if you want to implement that, you can do that. In that case, you have to create data frame for all the 5 tables, and then you join those tables one after the other and get order date, department name, and order item subtotal, and aggregate by using group function. If you want to do that, you can do that. And if you run into any issues, you can log those issues under discuss.itversity.com. Okay, any questions here when it comes to data frame operations? While you ask question, let me go to the next one, which is data frames SQL. Okay. And if you want to use SQL rather than data frame operations, all you need to learn is typical SQL in big data context, which is nothing but Hive. And most of the Hive queries you can run directly on data frames. Only thing is, your tables are not pre-created. First, you have to create case classes for the data set, and then apply map function. Once you apply the map function, you can register, apply the map function and create objects of that case class type and convert it into data frame. Once you have it as data frame, you can actually register as a temp table, and then you can run SQL queries on top of temp tables. So we'll see that. It seems there are no questions. Now let me show how the same thing can be applied using Spark SQL. Instead of data frame operations, we will try to use Spark SQL, and we will see that. So here the steps are same. You just have to make sure you have Spark SQL dependency defined in build.sbt. There is no difference here. And then once you compile it, and once you launch SBT console, if you want to develop on your PC and if you want to come up with the code, you just have to import all these things the way we are doing, we have done earlier. I'm doing again here. And then you can create case class for orders and order items. Okay, so here I'm creating case classes. You can have these case classes within the same package or different package. It's up to you how you want to organize. Once you create case class, you can create Spark Conf and Spark Context objects and Spark SQL Context object. So let me run these two, and I will also explain the relevance of this set conf. Okay, Spark Context is already there. That's why it is complaining. I can create this one. Okay, now let us understand what is this. If you see the output of my previous execution, when I perform the data frame operations, okay, you can see that it actually executed using 200 tasks. Okay, by default, when you use Spark SQL, the number of partitions, the number of shuffle tasks is 200. As it is 200, each stage will execute using 200 tasks. irrespective of your data size. That is default. And for our query, for our data set, which is very small, using running 200 tasks is not good, is not efficient usage of resources. If you want to change the number of tasks that will be executed, the number of tasks that will be forked to execute our query, you have to use Sql Context.setConst and set Spark Sql shuffle partitions to whatever value you want. Now, if I run the previous one, it will only use 2 tasks, not 200 tasks. So this is the relevant. This is related to that, and I'm importing this again. Okay, so here let me take this as the base path, and let me make sure that this path is correct. This path is not correct. I have to use ITversity here. Okay, and let me validate that. Yes, it is correct. And let me give the output path also. And output path also, let me change this to ITversity. I pasted in wrong window. Okay. And then here I am just validating that input path does exist and output path does not exist. So input path exists and output path also exists. So I have to delete that. So as I have to delete that, I want to run this. Okay, now it is deleted. Now, as I have done earlier, I am just applying map function. And as part of the map function, I am passing the data for orders and order items and creating data frame out of it. This I have done earlier also, so I am not going to spend much time here. I will just copy paste this one. Sure, Ramesh, this is the URL. Okay, once that is done, you can now. Okay, I think there is some issue here. It is still using the data frame operations. Probably 1 minute. Am I in the right one? Ideally, I should be registering temp table. Yes. Yeah. So here, so this was this I need to fix. Actually, this is not correct. So let me take it from here. Okay, and instead of using data frame operations, now what I am trying to do, I am registering orders as temp. So orders df is the data frame, and I am registering it as temp table, and the temp table name is orders. Okay, and you have to be careful when you try to give the names. Our case class names is this one, orders. Orders data frame name is orders df, and the temp table which I am using is orders, which is this one. So after this, if I want to run queries, I just have to use this as table name. I should not use this one or this one. This one is our case class name, which is used as part of the map function to create the orders RDD of orders objects, and then I am creating data frame, and the data frame name is this one, and then I am registering the data frame with this table name. Okay, so now what I can do, I can say Sql Context .sql. Okay, you can, if you have doubt, you can just hit tab, and there is SQL function here, and then you can run the query here. Select star or select star from orders limit 10. Most of the high queries will work without any issues. And then if you hit enter, it will just give, means when you actually invoke SQL, again the results are nothing but data frame type. If you want to see the results, you can convert it into RDD. So you can say dot RDD. Or I think here also probably there could be collect or something. Collect. Yeah, we can use collect and then for each println. Now you see the data. Okay. If you want to make it column specific, you can also give the column names here. Order ID, order date, and hit enter, and you can see only order ID and order date. Okay. So now if I want to get, if I want to get revenue for each date, I just have to join the two tables. So you should know SQL where and how to join in SQL, and then you have to know how to use group by, and then compute the revenue for each day. So here I will not spend too much of time on SQL. It's simple SQL. I am just joining orders and order items here on order ID and order item order ID, and I'm using where condition to filter for only completed records, and then group by, and as part of the select clause I am saying sum of order item subtotal, and then I want to display the data order by order date. So I am creating a new data frame here. What is the issue? Table not found order items. So okay, I haven't run this because I didn't register order items. It was complaining. Okay, and then we can run this. And then you can say total revenue daily dot collect dot for each println and hit enter. I think there is some issue with the query. It did not give the results. Let me see. Let me try this. I don't know why it is running these many tasks. Something is wrong. Okay, let me kill this. Something is wrong. Let me run again. I'm creating case classes for orders and order items. And then I'm importing these things. I have to give the input path. The input path is this is the input path. And output path is this is the one. And then let me run this. Okay, now let me say SQL context dot SQL select star from order items limit 10 select for each interval, and it looks good. Now let me run this query. Okay, now let me say total revenue daily dot select for each interval and hit enter. Yeah, now it looks good. Now if I say total revenue daily dot RDD, save as text file, now it is done. I don't know why it failed last time, but now you can see that it is successfully done. And if I go here, I think what is the output path I have given? Let me see the output path. Research output average revenue plus -LTR. You can see there are two files because we have given shuffle as two, shuffle partitions as two. There are two files, and you can see the data. Okay, so here you can see each day and revenue for each day. So this is how you can use Spark SQL after creating case classes and registering. First, you need to create case classes and then apply map on the input data and convert into data frames by using case classes apply method like this. And then you have to use register temp table to register them as temp tables, and then you can run whatever query you want on top of it. Most of the valid Hive queries will run without any issues. Okay, so that being said, I will give an exercise tomorrow on the data frames, and after this, I think there is one more which I need to cover as part of the data frames, and then we will wrap up the Spark and Scala workshop. Yeah, the next one is Hive in Spark Context. So I will cover that also, how to run Hive queries in Spark Context very briefly. But more important is how to create data frames on the data where there are no Hive tables. The way I have shown, creating temp tables and writing queries on top of it. If you have tables already in Hive, without creating these case classes and creating data frames using those case classes and registering as temp tables, we can directly connect to Hive Metastore and start writing queries against those tables. That we'll see tomorrow. It is pretty straightforward compared to this. And then I will give an exercise, and then we will wrap up with Scala and Spark. Okay, so here I will give couple of minutes time. What is that? That's for next class. Sorry, there is no class tomorrow. Yes, on Monday, and then there are no classes on Tuesday and Wednesday next week. I will cancel the Webex invite for Tuesday and Wednesday next week. Okay, so any questions here? I will give 1 or 2 minutes time. If you have any questions, I will take those. Otherwise, we'll wrap up and start with the second part of the workshop, which is high. And data frames is very, very important after core Spark APIs, because whenever we have structured data using data frames, we can reduce our development timeline significantly. Okay, it seems there are no questions, so I will be wrapping up the session, and then we will catch up in the Hive session. So I will keep you on mute for a few minutes, and then I'll be back. And also I will be stop sharing my screen. So those who are on Hangout, thank you very much for joining the session. If you want an environment to practice whatever I'm explaining and streaming it for free for the regular audience, even though this is primarily for Webex people, you can sign up for my lab at labs.itvarsity.com. And these are the plans: 14.95 for 31 days, 34.95 for 93 days, and 54.95 for 185 days. And even if you subscribe or not, if you are enrolled for my live classes or not, still you will get support. If you run into any issues, you can go to discuss.itvarsity.com and start logging the issues. There are an army of volunteers who are responding to the questions on not only just me. So your questions will most likely will be answered, even though you are learning at your own pace by following my content for free. Okay. So that being said, I will stop sharing. I will stop broadcasting this live session, and I will kick off a new session, and I will be talking about Hive. So stay tuned and join that session. Thank you. Bye.